Hey everybody, Mr. Carr again. Today we're going to be talking about 10-3 day one. Just like we did a deeper dive in arithmetic sequences, we're going to do a deeper dive in geometric sequences. Now, arithmetic followed a linear pattern. Geometric is following an exponential pattern. So we get a slightly different equation to represent that. So a lot of the stuff, again, carries over. We talk about the nth term being a sub n. We start with the a sub 1 term, and the common ratio is r. Then we can set it up as this: a sub n equals a sub 1 times r to the n minus 1. Now, how this might look like in terms of exponential patterns would be if, again, I do it in terms of a sub 0. So a sub 0 multiplied by r to the n. This is very much a y equals a times b to the x power. That's how it's an exponential pattern. Okay, so again, we just turn it, instead of n minus 1, we can make it an n, and we can set it up this way. Now, again, for our sequences, we are going to focus on the a sub 1 formula. This will be our main goal here. So let's use that a few times here. First case, find the sixth term of a geometric sequence for which a sub 1 is -3 and r is -2. Again, if you want to, you can list out all the terms going from a sub 1 all the way up to a sub 6. But I want to do a little bit of a shortcut. So I'm going to say this: a sub n is equal to a sub 1 times r raised to the n minus 1 power. So in this case, it'll be a sub 6 is equal to a sub 1, which is -3, multiplied by a common ratio of -2, raised to the 6 minus 1 power. So we get some weird stuff going on with our negative signs, and that's okay, because they'll just kind of, if you look at this geometric sequence, it would go bounce back and forth between positives and negatives. A sub 6 is equal to -3 times -2 raised to the 5th power. Since it's raised to the 5th power, that -2 is going to stay a negative sign overall. So that'll be a -3 times -2 to the 5th, which is a -32. Okay, and then my last thing is to multiply that by -3. So a sub 6 is going to be -32 times -3 for 96. Okay, so that's my final, or that's my sixth term in this sequence. Write the equation for the nth term of the geometric sequence below. So again, we're not given the common ratio, but we're given enough information here. If I make a slight modification of what we did before, common ratio could always be a sub n, a sub n divided by a sub n minus 1. What I'm saying here is I take any term in the sequence divided by the previous term. So in this case, I could do 10 divided by 5, which is 2. Doesn't matter which I picked, because I could have done 20 divided by 10, which is 2. 40 divided by 20 is 2. Okay, so we've established my common ratio is 2. A sub 1 is here. So that means a sub n is equal to my first term, which is going to be 5, multiplied by my common ratio 2, raised to the n minus 1 power. And that's it. Okay, so very similar. If I wanted to do a sub 0, I could. But remember, if this is going times 2 going that direction, I'm going to divide by 2 going the other way. I'm doing the opposite, or multiplying by 1/2. So I could treat it as 5/2 as my a sub 0. So 5 divided by 2 is 5/2. So technically speaking, I could do this. I could do 5/2 times 2 to the n power. But again, stick with this one for our purposes for this unit. All right, just want to connect back to those exponentials. All right, so write an equation for the nth term of the geometric sequence below. Just like before, we're going to use the formula, plug in what we know, and see what we can find. We need the first term, and that's the one I'm missing. But a sub 5 is equal to a sub 1 times r raised to the 5 minus 1 power. That's the setup we're using here to help us find a sub 1. We know r, we know a sub 5. So 4 is equal to a sub 1 times 3 raised to the 4th power. Okay, so 4 is equal to, that's going to be 3 to the 4th power, so that's going to give me 81. So this will be 81 times a sub 1. Divide both sides by 81 here. So my first term in the sequence is a fraction. 4 over 81. So we do want to write into an equation now. So that I can say a sub n is equal to the first term, 4 over 81, multiplied by 3, raised to the n minus 1 power. Okay, again, just using the formula. What pieces do I know? How do I use that to find the unknown pieces? All right, find geometric means. So just like we had arithmetic means, we have geometric means as well. I want to find the 3 geometric means between these numbers. So again, that's going to be a sub 1. And if I think about there's 3 geometric means, that means there's going to be 1, 2, 3 numbers in between, making that a sub 5. Okay. So what's happening here is as I move on, I'm going 1, 2, 3, 4, multiplying by r that many times to get into that, to get from a sub 1 up to a sub 5. So keep that in mind. How do we represent this repeated multiplication idea? Well, we'll still use the formula. If we know we're going to use a sub 5 compared to a sub 1 times r to the n minus 1 power. That's my setup. So a sub 5 in this case is 49.92. A sub 1 is 3.12. Then r is unknown, so I'll leave it like that, but then I'm going to have 5 minus 1 up there. All right, so I'll do 2 things at the same time. I'm going to divide both sides by 3.12, and I'll go ahead and subtract 5 minus 1 here. So 49.92 divided by 3.12 gives me 16. Is r to the 4th power. To undo this, we're going to take the 4th root of both sides. So use that in your calculators, do the 4th root, but you come up with plus or minus 2 for my r. Now, because it was an even root, we can do a plus or minus version of this, okay? Because I can plug in positive 2 or negative 2 here, and it gives me the same thing. Same thing if I do this here. If I do times 2 times 2 times 2 times 2, that's multiplying by 4 2s. If I do negative 2s, that's negative, 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 negative. That's 4 negatives. That's still a positive in the end. So these numbers are actually unaffected that way. Oh, real quick. Remember I said there was 4 r's I'm multiplying here? Directly related to that r to the 4th power. It's exactly what we're kind of modeling with that part right there. So that means I have 2 possibilities. I want to consider both positive and negative. My 3 geometric means, if it's a sub 1 is 3.12, I can do 3.12 times 2 is going to give me 6.24. Then times that by 2, I get 12.48. That times that by 2, I get 24.96. If it was a negative 2, so this is r equals 2 here. If it was the negative 2, my 3 geometric means would actually be negative 6.24, but still positive 12.48, and then back to a negative 24.96. Okay, so that's my geometric means in these cases here. All right, and that is it for today. So again, we're just using the formula a sub 1 times r to the n minus 1. How do we use it in different cases and see where it matches up? So if you want to pause the video, try this one out. Pause it, try this one. And feel free to pause it and try this one. Oh, one more. And then try this one. Okay, but that is it for today. So take care, everybody.